fantastic speaker, Professor Paul Bartha, from the University of British Columbia in Canada. This is my son who wanted really to enter this meeting too. Sorry for that. Before we start, I would like to say a few words about very sudden news about our friend, Professor Anand Jayaprakash Vaidya, who recently passed away and left us. Well, he was a very, very important person for us. He was a full professor at San Jose University in California. He was also a great member of our society association, Logic and Religion Association, and member of the executive board. We had great plans. He wanted to organize the next Logic and Religion Congress in California. He was a fantastic person. Everybody who knew him knows what I'm saying, actually. So I would like to take this opportunity to pay him the tribute as a great, great professor and friend. And I would like to ask you all to honor him with a moment of silence. Thank you. We will all keep him in our memory for sure. Okay, now I would like to introduce again our speaker for today's session, namely Professor Paul Bartha from the University of British Columbia. A logician, a philosopher who specializes in both logic and philosophy of science, as well as theory of decisions. He published in this topic, sorry, but also published a book about analogy. So reasoning is also something that you, Professor Bartha, focus on, yes. And the title of today's speech will be related also to one of the topics that you covered in a few articles already published. It will be related to Pascal's wager and also some positive reply to the problem formulated by Graham Oppy, as I know. So we are very, very curious about the details, and the title of the talk, as you all probably know, is Evolutionary Models and Relative Infinity in Pascal's Wager. It's my great honor again to chair this session. After the speech, of course, there will be a time for discussion. And now, Professor Bartha, the floor is yours.
Thank you very much. So I wanted to give my thanks to Assis for inviting me, and to all of you for being here and attending. I feel very welcome. And for many years, I've been interested in Pascal's wager and sort of applying formal techniques to think about infinite decision problems, such as Pascal's wager. So I'm happy to have the chance to talk about it, and looking forward to your comments and questions. I'll share my screen, I guess, here. Let's see. Oh, I don't know, is that working?
It is, yeah.
You can see it's vanilla slides. I'm not great with visuals, but anyway, so without further ado, so evolutionary models and relatively infinite utility in Pascal's wager. So as I mentioned, a big interest for me is how to extend standard decision theory to infinite decision problems, infinite utility, infinite act states, and so on. And there's a sort of a desire to have these three qualities in any such framework, that it should be neutral. And so don't build in crucial assumptions a priori. It should be plausible. And in particular, when we're talking about infinite value, what we mean here is the concept of infinite value that's introduced in Pascal's wager, or other problems should be clear, non-arbitrary, and it should be fruitful. So the framework should give us resources to think about problems old and new. So that's the big question. Then the smaller question, although it's still pretty big, is how to think about the infinite utility in Pascal's wager. And also this other aspect, which I'm interested in, is the dynamic aspect. So Pascal talks about, he uses this metaphor of a journey or a road to faith. So it's not as if the wager is this one decision and then it's over. So that is an interest to me as well. So the main claim I'd like to make is this model I've been developing, which I call the many wagers model, offers a neutral, plausible, and fruitful framework for thinking about the wager. Not that it solves all problems, but it's helpful in these respects. In particular, I think that we have a good representation of infinite utility and a good way of thinking about the evolutionary aspect that's implicit in the wager. Okay, so the way I'm going to proceed is I'll just briefly talk a little bit about Pascal's wager, and then an initial set of objections, which are fairly simple in a way and widely recognized, and there are lots of different ways of addressing these. I'll then introduce this relative utilities and many wagers model. There are these two aspects, and I'll show how these models can be used to respond to some initial objections. If I have time, I might briefly look at some other models that people have and make some comparisons. Then I'll turn to these more complicated objections and responses that were raised by Graham Oppy. So these are, Oppy's objections are specifically to this many wagers model, but I think they also can be seen as particular versions of very general objections to Pascal's wager. So I'll talk about them in that way and then conclude. So that's the plan. So this argument is one of the most famous in philosophy. Everybody has seen this, so I don't need to belabor it. But the fact is that there are different versions of Pascal's wager. Perhaps the canonical or simplest, most familiar version, it looks something like this. So a 2x2 decision problem. The options are wagering for God, which means something like it's an action. So taking steps to bring about faith or belief. Wagering against includes everything else. So everything from being just indifferent to trying to lower your credence. And then the possible states in this very simple version, God exists or does not exist with some probability P. And then the outcomes are infinite in the top left corner. If you wager for God and God exists, there's this infinite reward of salvation, or even like a probability of that reward. So we put an infinity there. And then I just put a dot for the other outcomes, which indicate finite utility. This is the version that's often used. So if we apply a kind of naive expected utility maximization here, we see that wagering has infinite expected utility because it's p times infinity plus 1 minus p times something finite. So that's infinite. So wagering has infinite expected utility. Wagering against is finite. So, and it doesn't matter what the value of p is, so long as it's a positive real number. So it's rationally preferable to wager rather than not wager, or rather than wagering against. Okay, so Alan Hayek has this nice way of summarizing the argument in terms of the three premises, that the decision table here reflects the way the agent sees the choice. So I'm setting aside, in particular, finite versions of the wager. They'll come up later in discussion, but where you just put large finite utility in the top left. So I'm going with the infinite because that's my interest, is infinite utility. But anyway, so that table reflects the agent's choice, that the probability is a positive real number, and finally, that a rational agent should maximize expected utility. And it has to be acknowledged, this is a slight extension of standard decision theory because we don't have infinite utility in standard decision theory. Okay, so here's a summary of all the objections I'm going to talk about. There are others. There are other objections which people may raise, but some of the most familiar. So what I call the simple many gods objection. So the idea that we need more rows and columns. There could be other gods who offer infinite utility, and therefore lots of different choices have infinite expected utility. So you're either getting contradictory recommendations or you're paralyzed because there's no guidance when just about everything you can do has infinite expected utility. Then there's this mixed strategy objection, which I'll get to in a moment, but why not toss a coin to decide whether to wager? That seems to have infinite expected utility. And then the one I'm particularly interested in is an objection to the concept of infinite utility itself. What does it mean? And how does the mathematics work? It looks kind of dodgy, this reasoning with infinite expected utility. So I think these three objections are all linked to the way we represent the utility and the infinite utility in the wager, and they can be addressed by a better representation than just using the simple extended real numbers with the infinity. So that's the first three. And then the more complicated objections. So the general way of putting these, the fourth objection is a kind of universalist intuition that a worshipable God should not be as partisan and sort of exclusivist as Pascal's God. So wagering for Pascal's God is ethically problematic. The fifth one is a kind of evidentialist objection that's very familiar, that there's no basis for updating your probabilities on pragmatic or prudentialist grounds. Only evidence is acceptable as a basis for updating. And the sixth one, which I'm especially interested in, is the argument that we need to consider infinitesimal credences, deities to whom we assign infinitesimal probability of existing. This leads to a kind of explosion of the many gods problem. And it looks like the whole thing collapses, right? Once we have just something just a little bit more than bare possibility, the argument becomes problematic. So I think these are deeper objections. And in part, I'm going to argue they can in part be addressed by a better concept of infinite utility. And I think this evolutionary model. So I will focus on Oppy's arguments, which I see as specific versions of these three objections that apply to the many wagers model. So as I say, I'm not going to solve these in general way or even solve Oppy's. Oppy has some very good arguments, but I think the thrust of my paper is that we can develop a useful model for thinking about and exploring some of these objections. Okay, so let's look at these. So the familiar many gods objection, the simplest version just says, why not assign positive probabilities to other deities who will provide this infinite reward? So,
okay.
Okay, I hope everyone can hear.
I'm sorry.
That's
Please,
okay.
everyone, turn off your microphones.
Oh yeah, that must be the problem. Okay, so in this decision table, we just add more columns and rows for other, what I'm going to call jealous gods. These are gods who only reward their own followers and nobody else. So we have a bunch of infinities on the diagonal and finite values everywhere else. So basically for each column, each possible deity, there's a possible wager. There's an infinite value at the intersection. So it looks like each choice has infinite expected utility, and the symmetry of the situation leaves no basis for decision. And of course, why not open up this pantheon, as I'll call it, of possible gods to others who reward everybody, who just reward atheists, who reward nobody, and so on. So since any act could have infinite expected utility, the argument provides no guidance. Okay. The mixed strategies objection, I'm guessing, will be familiar to a lot of people, but let's suppose we just add a mixed strategy option, a coin toss. So that's my new third row. And let's assume it's a fair coin. So you can see if we're still using this simple approach to expected utility, the coin toss, if you get heads, you wager, tails, you don't. So the expected value of the coin toss is a half times p times infinity, which is still infinity. So the coin toss is just as good as the pure wager. And Hayek points out you can just make this probability lower and lower. In fact, you can do your best to reject God, as long as there's some tiny probability that you might end up wavering and turning back and wagering, all of these acts have infinite expectation. So again, there's no basis for decision. It's very mathematically similar to the many gods objection, right? That is, we're just looking at other options that have infinite expectation. Now, there's a common response to these first two objections, which George Schlesinger developed, sometimes referred to as Schlesinger's principle. So in cases where the expectations are infinite for different acts, the criterion for choosing the outcome, or I guess I should say for choosing the act to bet on, or is its probability. So if you have a choice between an act that gives you a 90% chance of an infinite payoff and a 10% chance, you should pick the 90%. So it's a plausible principle, but it needs to be refined. It looks somewhat ad hoc if it's not embedded in a decision theory. And it doesn't help with the next objection, O3, or with more complicated versions of many gods. So let me go on to this third objection. As I said, this is one that's especially interesting to me. So what is the meaning of the infinite utility in the wager? What does it mean for a human being? And how is infinite utility compatible with decision theory? So those who know decision theory know that you can, when you think about utility, you can have what we might call a utilities first approach, that utility is something independently meaningful, some sort of measure of human happiness or pleasure or satisfaction. And on this view, infinite utility does seem meaningless because finite human beings, at least on the surface, can't experience infinite utility. John Broome has made this point. This could be contested. You could talk about finite utility over infinite time or something like that. But anyway, I'm not going to adopt this approach. The other way to think about utility is more abstract. This is a preferences first approach, where the fundamental object of interest is human preferences, and utility is just a representation of those preferences. So this is the approach I'll take, but even here there are problems with infinite utility. So the first is that, as we'll see, it violates what's known as the Archimedean axiom or continuity. And this is an assumption that is needed to justify the very principle of maximizing expected utility, as McLennan pointed out. So if we go back to Hayek's argument, let's see, the third premise is that agents should maximize expected utility. If you drop continuity, you've undermined the justification for that principle. Okay, so that's one problem. Another problem is, I like this dilemma that Alan Hayek raised about 20 years ago. If you're trying to designate some infinite value of salvation, even as a representational approach, you have this problem that on our simplest extended real numbers, where there's only one infinity, you get the mixed strategies objection. You can't discriminate a whole bunch of acts that seem different because they give different probability for the payoff. You can't discriminate them if there's only one infinity. If you move to what I'm going to call these Baroque number systems, complicated systems like the hyperreals, surreals, or lexical utilities, then you face it. You can solve those first problems as other theories do, but the choice or designation of any particular value for salvation seems arbitrary. There's a huge and sort of limitless range of infinities. Which one? How do you justify it? So anyway, there are problems with infinite utility. Okay, so that's sort of the first part, raising the basic objections. So now I want to talk about these relative utilities and the many wagers model. So there are two ideas here, and this does kind of go over a little bit of the work I've done before. So one is relative utilities. So the idea is we're not going to define absolutely infinite utility. We're going to define this relational notion of relatively infinite utility, and we'll give it a finite representation. And the second is this evolutionary updating model. So there's an analogy between evolutionary game theory that will give us a mechanism for updating our beliefs in various deities. Okay, so I'm going to talk about first relative utilities. So this is one of the more technical pictures, but I'll try to get the idea across. So what are relative utilities? Well, they're generalization of ratios of utility values. So suppose this symbol, the curly less than sign, designates strict preference. And suppose suppose A is preferred to B, which is preferred to Z. So in the interval picture, A is best, B is in the middle, Z is worst. Think of Z as like a 0 point. We're going to define this notion, script U, B, A, Z. This is the relative utility of B relative to A with base point Z. So the intuitive picture is B is some ways along the interval between Z and A. So in standard decision theory, you can just let it be the difference between the utility of B and Z divided by the difference between the utility of A and utility of Z, where U is an ordinary one-place utility function. And if you know, if you have an interval scale, this ratio will basically cancel out the arbitrary parameters that exist in a utility scale, an interval scale. Okay, but there's another way to think about this, this number. So in standard decision theory, we have the continuity axiom, which I already mentioned. So the continuity axiom says if B is intermediate between Z and A, if it's strictly intermediate, there is some probability P between 0 and 1 so that the agent will be indifferent between B and some gamble or lottery, which I'm using this notation PA, 1 minus PZ, to mean the lottery that gives you probability P of getting the good outcome A and 1 minus P of getting the outcome Z. So if that's the case, you can actually reduce star to just P. The relative utility will be this number P, this indifference point. Okay, so there are these two ways, they're equivalent. That's in standard decision theory. In relative decision theory, I'm not going to do any proofs, but it assumes all the standard axioms of decision theory except continuity. It doesn't actually assume continuity is false, but it doesn't assume it's true. And even without continuity, you can prove that there is still a unique value P between 0 and 1. And now you have to include 0 and 1. There's a unique value P such that B will be superior to the gambles to the left, where Q is less than P, and B will be inferior to the gambles to the right, where the R value, this is in the third last line, where the value is greater than P. But you cannot prove, without continuity, you can't prove that B will actually be, that the agent will be indifferent between B and that gamble. That sounds unimportant, but it's actually quite important for Pascal's wager. And then we basically define the relative utility as that same value. So once again, it's kind of a measure of how far along B is on the way from Z to A. Now, this always gives a value between 0 and 1, but you can extend this. If B is to the right of A, you can extend this definition to get values that are greater than 1. But the values will always be positive the way I've set it up. I always pick a base point Z. Think of it as where you plant your measuring stick. Always pick a base point that's worse than the outcomes you're comparing. Okay, so we are not going to need most of that stuff, but these three special cases are going to be important. So the first, and this is the most important, is the first. This is the definition of relatively infinite utility. So the A has infinite utility relative to B with this base point Z. And unfortunately, you kind of need the base point. You can sort of see it. The base point is like the fallback. If you're gambling, Z is like the bad outcome you might get. So it changes your assessment somewhat. Doesn't change the order, the preference ordering, but it changes your determination of the value of P. So here's the definition. A has infinite utility relative to B if you would prefer any gamble that gives you some positive chance of A to B. So you would trade the certainty of B for a gamble PA 1 minus PZ. so long as P is positive. This is kind of turning Pascal's wager on its head, right? So we're saying that's exactly the kind of preference a Pascalian has for God, that they think any finite prize is something they would exchange for a chance at salvation. So I'm making that the definition of relatively infinite utility. And notice that the definition is defined in terms of entirely kind of things you can ask people about their preferences. I'm not using any strange number systems, just real positive probabilities. Okay, so that's infinite relative utility. Zero relative utility is just the same thing, but we just swap A and B. So in the picture, if you look at the first picture, you can think of this zigzaggy bit in the middle of the interval as the discontinuity. So A is sort of up on this plateau that's infinitely better than B and Z. So B, in this picture, A has infinite relative utility compared to B when the base point is Z, and B has zero relative utility. The other picture is also quite interesting. So this is the picture for relative utility of 1. And the crucial point here is it doesn't mean, to say two things have relative utility of 1 doesn't mean they're equally good. So in my picture, A is quite a bit better than B. But the question is, would you trade B for a non-trivial gamble between A and Z, where you might end up getting Z, right? So the idea is you've got an infinity in the hand if you're at B. If you wouldn't trade it for any gamble between A and Z, except the one that where P equals 1, where you get A. So any non-trivial gamble would be inferior to B. Then we say A and B have relative utility of 1. And the same is true for A. So the definition just says neither one would you trade for a non-trivial gamble that might end up giving you Z, right? So that's the idea of equal relative utility. There's some things to talk about here. You might be wondering, what if there's other even higher plateaus, right? So other levels of infinity. So I'll come back to that a little later. Okay, so there's a kind of simplified way to think about all this stuff, which is to use what I call relative decision matrices or tables. And these are just the tables of the relative utilities. And relative utilities are like a first order assessment of the utility. It doesn't reflect everything, just the comparison to looking at sort of the best outcomes. Those get a value of 1, and the others are assigned a value according to their relative utility. Okay, so, and there's a simple proof that you can justify an expected utility maximization rule. You should maximize expected relative utility. Okay, so if we look at the original version of the wager, what happens is that outcome in the top left corner has the maximum. So that gets a 1. It's relative utility. You put everything in the table in terms of the base point and the best outcome. So you get a 1 in the top left corner, and the other finite values become a 0. And the relative expected utility of wagering is P plus 0 times 1 minus P. So is P, and the relative utility of wagering against is 0. So maximizing expected relative utility leads to a recommendation to wager. So that actually the conversion from standard decision matrices to relative decision matrices in the kinds of problems we're interested in, where there's at least one infinite outcome, we typically just replace each occurrence of infinity with a 1 and each finite value with a 0. So if you look at that second example, the simple many gods problem, the new table just has 1s on the diagonal and 0s everywhere else and on the whole last row. So now we can actually compute expected relative utilities for each row, for row I, or row K, I guess I should say. The expected relative utility is just a bunch of zeros and then 1 times pk. So it's just pk. It's the credence you have in that particular god. So to maximize expected relative utility, you just wager for the God that has highest subjective probability. This is Schlesinger's principle, right? So, but now we have a decision theory, a non-standard decision theory that agrees with that principle. Okay, you can get fractional values, but I'm just looking at sort of simple cases here. Okay, and of course, I should say, if you're dealing with all finite outcomes and there's nothing that's infinitely good, then this is just going to be standard decision theory. The values will just be normal utilities, normalized so that the best is a 1, the worst is a 0. So there's no conflict with standard decision theory, except that we do allow infinite values, and there's discontinuity here. Okay. So let's see, how does this help us deal with some of those objections? Well, we've already seen how we respond to the simple many gods objection. It's resolved, as we just saw, in agreement with Schlesinger's principle. The same basic strategy will help us solve the mixed strategy objection. So here in the middle of the page is the table, but now it's the relative decision. So you just put 1 where you had infinity, and now the expected relative utility of the coin toss is 1/2 p, where p is the probability that God exists. That is less than the expected relative utility of the pure wager, which is p. So we still have an argument that we should wager instead of flipping a coin, right? So again, this is what Schlesinger's principle would tell us. What about the third objection, the objections to the concept of infinite utility? Well, first of all, we're talking about relative, not literal infinite value. So we don't have that first objection that humans can't experience infinite utility. We're not trying to think of utility as a measure of happiness or something. It's a representational device. What about the haziness or imprecision? Well, actually, we've got a definition of relative utility in terms of just well-defined preferences and real valued probability. So we've got a nice, clear notion of infinite relative utility. So we don't have that problem. What about the problem that we noticed about McLennan's problem that we've undermined EU maximization when we drop continuity? Well, actually, there is a proof, a representation theorem, that even without continuity, we get a utility maximization result. And finally, Alan Hayek's dilemma about how we represent infinite value, we've kind of got a bit of the best of both worlds. We're still just using the infinity symbol or a 1, so we don't have an arbitrary designation. You would have that if you had a one-place utility function and you had to pick some hyperreal or surreal number. We don't have that problem, right? So we're just doing three-way comparisons, right, in each of these relative utility tables. Each of the values represents a three-way comparison. Okay, so at least on the surface, it looks like we've got a framework that addresses these first three objections. Okay, so a few clarifications, because it's natural to be kind of puzzled about some features of this theory. So again, it looks like we're saying all these infinite outcomes are equally good. They're all getting a 1. Well, they're not exactly equal. And now we need to come back to this issue about what happens if there are different levels of infinity, right? So I am a fan of what I'm going to call this parallax postulate. So I think if there's a finite outcome in the table and one or more infinite outcomes, they should all have relative utility 1. But that is an option. That's a modeling assumption. It's not built in. So the reason I think this is really just, again, it's this bird in the hand argument. If Z is some finite outcome, the base point, B and A are both infinite, and A is much better infinite, is any non-trivial gamble between A and the Z, the base point, is that worth trading away B, if B is guaranteed? And I know you can make P as small as possible, sticking to real valued probabilities here, right? So that's crucial. So my answer is no. The parallax postulate says no. And that, again, is in line with Schlesinger's principle. It is optional, however. You could insist that there's these little levels of infinity. There's another zigzaggy break and A is off at a much higher level, you could insist that B has relative utility 0. B is the sort of intermediate infinity. You could make it 0, it's allowed, but I think this parallax postulate is plausible, and it greatly simplifies the decision theory. So I'm using the term parallax by analogy with stellar parallax. So stellar parallax, the distant stars, you can observe some motion over time, right? If of the less distant star relative to the more distant. But my thought is, if you take this to infinity, if both of these stars are kind of levels of infinity away, you wouldn't actually notice the motion. So that's kind of why I like this term. So I think, it's good enough. It's maybe you could call it infinite satisficing or something. I don't know. But anyway, let's keep it as a modeling assumption that there's room to reject it, but I think it's plausible. What about the finite outcomes? That's the other problem with these tables. They all seem to get a 0. You're erasing the very important differences among the finite outcomes. Again, a relative decision table, it's kind of like a first derivative with respect to infinity or something like that. So you don't actually see the differences there, but they're there. And if you switch your base point and your upper bound, you can see the differences at the finite level. So it's just that these relative decision tables are adequate for most Pascalian decisions. Okay. So why do I think this is a neutral? Remember, I talked about neutrality. I talked a little bit about, what did I say? Neutrality, fruitfulness, and plausibility. So I think the plausibility was about the clarity of the notion of infinite utility. I think it's a clear notion. Neutral because, in fact, I'm not insisting on the parallax postulate. It's not baked in. And neither is continuities. I'm not rejecting continuity. It's just that the framework doesn't presuppose it. So if you want, that can be a modeling assumption that we insist on continuity, and then you'll have to just use, it will look like standard decision theory in that case. Okay. So the theory is like an extension of standard decision theory, not inconsistent. Okay, now we're starting to move into harder territory. So the problem is we need to widen the field, especially thinking about many gods problems. So there are other possibilities. There are jealous gods, which we've been talking about. There are nice gods who reward their followers and at least one other group. Universalists reward everybody. We could think about grouchy gods who don't reward their followers but reward at least one other group. There are other possibilities too. It turns out you can get some help from relative decision theory. Okay, so let's look at an example. So here we've got a jealous god and a grouchy god. And if you just look at the naive standard decision table, we've got an infinity at the top left and an infinity, not wagering for the grouchy god, because the grouchy god doesn't reward its fault, but this grouchy god rewards the atheists who wager, or those who wager against all. Okay, so this is a kind of stock example, and it's true. The standard decision theory is no help. It looks like each of these choices has infinite expected utility. If we move to the relative decision matrix, then the expected relativity of the first option will be Pj, the credence in the jealous god. The expected relative utility of the middle option is 0. The expected utility of the bottom option is Pg. So you get at least a first decision, which is if you assign higher probability to the jealous god, you should wager for that one. If you have higher credence for grouchy god, you should wager against all. I'm going to come back to this example, but so there's at least a little bit of progress. Now we come to a kind of grim result for the model, for the relative utilities model. So let's compare this jealous god to a universalist that rewards everybody. So if this nice god exists, then everybody is rewarded with salvation. It's universal. So we have an infinity in the entire second column. In the first column, only the followers of the jealous god are rewarded, and everything else is finite. So again, standard decision theory has nothing to say here. All options have infinite expected utility. If we move to the relative decision framework, we replace the infinity with 1 and the dots, the finite values, with 0. Now you can see what's going to happen. The expected relative utility of wagering for the jealous will be Pj plus Pn. The other two options, it's just Pn, which is the credence in the nice God. So it looks, in fact, it looks like dominance, and it is. The wagering for jealous, as long as the probability that jealous God exists is positive, you should wager for the jealous God. And the way of putting this is nice gods finish last, right? So there's, on this Pascalian framework, there's no incentive to wager for the universalist deity. And I think this is prima facie a problem for the model, right? And maybe it's a problem for Pascal's wager as a whole, but it's certainly a problem that gets inherited by this approach. If you think we need a theory that gives a kind of shows why that model is, why belief in the universalist God is a stable kind of belief, then we've got a bit of a problem. Okay. So let me start motivating this idea that why we need an evolutionary model. So consider that, go back to that example of jealous and grouchy. Let me see if I can find it. It was right here. So there's something strange about this reasoning, which is that we showed that you should wager against all if your credence in the grouchy God is higher than the credence in the jealous God. However, what's odd about this is you don't end up wagering for the grouchy God, you end up wagering against all, which naturally leads to taking steps to reduce your credences in all deities, but in particular in the grouchy God. So it's a kind of self-undermining result that, on the other hand, wagering for jealous is actually self-sustaining, right? You start raising the credence in the jealous God, it's going to all be pushing that probability upwards. So essentially, it looks like if we start thinking about the wager and what happens next, we might say, okay, what happens if you wager for the grouchy God? You start lowering your probabilities in all of these deities. Maybe this will undermine your resolution to wager for the grouchy God, right? So this suggests a shift to a dynamic view and a quest for what we might call stable credences under this kind of evolutionary pressure. Okay, so the many wagers model, the basic idea is you have this dual role for credences. They simultaneously are your subjective probabilities for each of the columns, each of the gods, and they also reflect the strength of your inclination to wager. And the idea is, rather than choosing one wager, you assign weights to all of them according to your current credences. You evaluate relative expected utilities for each wager, and then the ones that have above average expected relative utility get bumped up. The ones that are below average start dropping. And the details of the model aren't so important. What's important is stability. A viable set of credences needs to be stable under this rule. So there's actually an analogy here with evolutionary game theory. If we think about groups in a population employing strategies, there's some starting proportion. You look at relative fitness, and the groups that have above average relative fitness increase. And then we have a notion of equilibrium and stable and unstable equilibria. So if we carry these over to Pascalian decision problems, the analogy would be between groups and different theological possibilities, strategies, and wagers. And relative fitness is analogous to relative expected utility. So we're looking for equilibrium credence sets which are stable, which don't experience this kind of upward or downward pressure. Okay, so this is the other technical slide, but I'm not going to try to go over the whole model. But this is basically just the replicator dynamics from evolutionary game theory. But the idea is, if you look in the middle, you think of each stage as one step. So if you start with some distribution pi to deity I, as it were, then what you do, uwi, that is the relative expected utility attached to wagering for that deity. U bar is the average, the weighted average expected relative utility. And pi prime is the next stage credence in that deity. So what you do is you just look at the the relative fitness of that wager compared to the average. If it's greater than 1, PI will increase. If it's less than 1, PI will decrease. And for an equilibrium, all of these should be 1, right? They should all be on the average. So that's the idea. So for an equilibrium, there should be no change in these credences. And then we can introduce a notion of stability. So in population dynamics, the idea is if you were to get a small perturbation in the population, the equilibrium would be restored. We can think of the same thing. So if you have some stable equilibrium and somehow the probabilities were to get pushed around a little bit, your credences were pushed around, they would return, they would reconverge. That would be a stable equilibrium. Okay, so, but in fact, I am not that serious about this, the particular model. I'm not that attached to it. The equilibrium is the basic idea. Just, is this wager above average or below average? That's the important point. Okay. So if we go back to those examples, now we can think a little bit more about the examples we've seen. In the original wager, the relative expectation for wagering against all is 0. The relative expectation for wagering for is PJ, the probability that God exists. It turns out if you apply this model, then P prime jumps to 1 after a single iteration. I don't think this literally means that you should instantly have probability 1 that God exists, but what it shows is that intermediate probabilities for God existing are unstable in some sense on this model, that there's upward pressure on the probability that God in the original wager. If you look at the scenario with many jealous gods, that was the diagonal values were 1, then if one of them has highest initial subjective probability, that will converge to 1 on this model. The others will drop to 0. If there's initially a tie among n of them, then they will all share that credence at equilibrium 1 over n for each of them. If you look at the scenario with the jealous and the grouchy god, what happens here is also interesting. Basically, if you start with positive probability for the jealous, the grouchy, and no god exists, then the probability that the grouchy god exists drops to 0 after 1 iteration, and then the probability that that there's no god drops to 0 after 2. So again, I don't mean this to be taken literally, but it's a point about stability. The only stable equilibrium values are assigning probability 1 to one of these 3 options, that the grouchy god exists, the jealous god exists, or no god exists, and only the first of those is stable. So this is somewhat stronger result than the initial discussion. Okay. So what remains, however, so we've seen that if you look at this many gods objection, keeping an eye on time here, that we kind of can solve some of these simple many gods problems, even for some of the more complicated scenarios like the grouchy versus jealous. The many wagers model can provide some help in ruling out non-equilibrium distributions. But there are still lots of problematic many gods scenarios, and this is where Oppy's criticisms start. So I'd like to start moving to, I think I'm going to skip this one. This is something it could come up in the question period maybe. This is a comparison between the relative utilities framework and these other ways of representing infinite utility. So I'm going to skip this for now. If it comes up in questions, I can come back to it. So let's look at, this is sort of the last part of the talk. I hope I'm still okay on time. So this is the universalist objection. So the broadest version of the objection is that there's something morally problematic about wagering for an exclusivist deity who's kind of partisan in the way that rewards are doled out. So Moser writes that basically God should be worshipable, worthy of worship, and the Jansenist God, this is Pascal's Jansenism, the Jansenist God's character fails to determine that the outcome will be infinite gain, given the exclusive morally suspect will of that God. So the point here is we should not regard infinite salvation from that deity as infinitely valuable. It's flawed. So we don't assign it infinite value. So this, and remember, we had the specific version of universalism that's a problem for the many wagers model is that nice gods finish last. So there's the broad problem, and then there's the problem for my model. You could argue it's a problem for neutrality. The many wagers framework is not neutral because it seems to rule out universalism. Okay, so I have a couple of possible responses here to this worry. And then I'm going to just briefly I'll get to Oppy's particular version of this in a moment. So one general response would be to agree with Moser. So take the ethical approach. Only the universalist deity gets relative utility 1. So here's the table for jealous versus nice revisited. So before I had a 1 in that top left column, wager for the jealous god, and the jealous god exists. That was a 1. Now we're putting a 0 because it's morally flawed, right? It's finite or even bad. So we don't give it a 1. It's not comparable to the salvation from the universalist deity. Okay, so what happens here? Well, it looks like all 3 wagers are tied if you just look at the first order relative decision table. However, this is when you get ties, you can go to the actual preferences and break the tie in favor of wager for B, wager for the universalists. There could be an argument that it's better to wager for the universalists. That's morally superior. So you can break the tie. So you can solve the problem here, but it seems like a heavy-handed way to defend universalism within the many wagers model, to import a substantive ethical position into decision theory. So my thought was, is there a way universalism could emerge while still granting that these various salvation outcomes are all equally good? So without applying the ethical constraint. And that is what I call this lazy limit approach. It's lazy in a couple of ways, but it seems like a universalist deity can kind of emerge as a cartel of nice deities. So it is early in the morning, but this is a little bit hard to, it's a bit humorous, but so here's a picture for a cartel. So the 2 gods in the top left corner form a nice cartel. They reward each other, their own followers and each other's followers. So you get 1, 1, 1, 1. There's a jealous god C, and then there's the possibility that no god exists. So what happens is, if you look at the many wagers model, you see that the nice cartels behave like a single jealous god. So in particular, if the sum of their 2 probabilities is higher than the probability C of the jealous god, then the cartel will take over. They will go to 1. The probabilities that one of them exists will go to 1. The probability for C and D will drop to 0. And Oppy he calls them jealous cartels, but it's the same idea. So Oppy says these gods are kind of non-fussy. They say you just believe in someone enough like me to get salvation. I call it lazy for a couple of reasons. One is, suppose this actually takes over. It's a kind of a universalist solution, but it doesn't require much commitment. It's very little commitment is required. If you think basically whatever you do is fine, you'll get this infinite reward. It's also lazy because it's lazy for me because it's not really solving the universalism problem. Wager against all is not rewarded, and mutant deities might emerge and they wouldn't be rewarded, right? So it's a sort of a partial answer to this objection about you. So you can see a kind of universalism might emerge, but it's not genuinely universal. Okay. So Oppy thinks that the cartels create 3 challenges. There's a counterexample to stability. This is a minor point, but remember that stability requirement is if you take an equilibrium and you sort of perturb things a little bit, you'll return to the original equilibrium. That does not happen here. You can sort of see why. If you've got, sorry, now I've lost. If you have all of your probability distributed over the nice cartel, if you redistribute from A to B, there's no pressure to go back, right? So, but in a sense, it's stable in the sense that the probability for the nice cartel remains at 1, and that's stable. So I don't think this is, Oppy says, strictly speaking, this is a problem. He's right. It's a problem for the stability requirement, because there doesn't seem to be anything wrong with this nice cartel. The big objection he has is he thinks nice cartels will defeat jealous gods, which he sees as sort of more conventional religion. He assumes equal prior distribution. So if you have a picture like this one, you start with equal priors, then you can see why the cartel will win, because A plus B will be higher than C. So he says a nice cartel will beat a jealous god, and in fact, a bigger nice cartel will beat a smaller nice cartel. So this is the third point. So he says, in fact, the updating rule redistributes probability towards bigger jealous cartels, and this will lead to infinitely large cartels, and everything blows up here. So it's kind of a clever objection, but I think equal prior credence is not mandatory. So if you assume that, yeah, he's right. Certain starting configurations could lead to this, but I don't think it's mandatory. So anyway, the upshot of all this, I'm not trying to say I've completely responded. I think the point is we've got a framework for thinking about these problems. We can get limited types of universalism, but the larger challenge remains. Okay, I'm going to talk to Marcin for a minute. I have two more objections from Oppy. Is it worth developing? Or
Well, yes, please continue.
Okay. So that's the end of the talk, is these two other objections from Oppy. And this is kind of what I wanted to get to, but all right. So evidentialism. So the broadest version of this objection is very familiar from as far back as the Clifford-James debate, that it's just wrong to update based on pragmatic prudentialist considerations. Your credences should only be changed based on evidence. So the ethics of belief. So I'm going to distinguish between a strict evidentialist view that rejects any non-evidential updating. I have no answer to that here in this talk. Others can talk about that. It's a good topic, but my starting point is that some such updating is permissible, right? Otherwise, we can't really get started on Pascal's wager. So I'm interested in this soft evidentialist position, which says, let's allow pragmatic considerations to bear on our credences, but let's also allow agents to refrain from wagering. So we don't restrict our table to wager for this, wager for that, wager against all. We have another option, refuse to wager, right? And Oppy has a really picturesque way of doing this. He says we should allow a Bertrand Russell style God. He doesn't use the Russell, but I think of it as like, if Russell said, if any God existed, it should be this one. It's the virtuous God who rewards atheists, who rewards rationality, right? So Oppy says, it seems intelligible that one might suppose the behavior of virtuous gods is motivated by respect for rationality and integrity. So we should allow positive probability to a God who rewards agents who refuse to wager. Okay, so and then Oppy goes on to say, if you include this virtuous God in the table, that undercuts the whole updating mechanism. It halts the march towards equilibrium. It invalidates, in particular, the case for the jealous God, right? So he says, we introduce a barrier to updating. We definitely do not get the conclusion we're not to wager on the jealous God. So here's Oppy's table with relative utilities. So we're thinking of this as infinite reward. So you get a 1 for the jealous God and wagering. You also get a 1 if you refuse to wager, and the virtuous God exists. But this is all still within the pragmatic framework. So we're still allowed to bring pragmatic factors to bear on making this decision. Should I wager for J? Should I wager for V? Should I refuse to wager? Okay, well, actually, there's no incentive to wager for V, right? So the choice is really between wagering for J or refusing to wager. Okay, so my response is absolutely, we should allow this virtuous God as a possibility. But we should think about what refusing to wager means. What it means, it doesn't mean it doesn't mean reject. It's not the same as reject or wager against. Refuse to wager just means, since there's no relevant evidence, leave your credences unchanged for J and V. So you start with some initial credences. Refuse to wager just means don't change them because you have no evidence coming in, right? So the basic framework, the relative utilities and the evolutionary are not threatened. And to see this, let's think about how we would apply those frameworks. And first, I'm going to do it without updating. So if you're just doing a straight comparison, you would start with some initial credences, PJ and PV. And you can pretty quickly see, it's kind of like the earlier examples. You should wager for J if PJ is higher than PV. You should refuse to wager if PJ is less than PV, right? It's going to follow from the same kinds of arguments. You just compare the relative expected utilities. Okay, with updating, you're going to get this sort of the same result, but it's a little more interesting, actually. You just need a slight modification. So you, first of all, will never wager for V, right? There's no relative utility. Even if PV is positive, wager for V has zero relative utility, right? If that middle row. So what you do is you compare the average, you compare the expected relative utilities for the first and third option to the average. The weighted average turns out to be PJ squared plus PV squared, but don't worry about that. It's really what you're doing is because there's only two of them, you just have to compare again PJ and PV. If PJ is above PV, the dynamics takes over and carries PJ to 1. If PJ is less than PV, this is the interesting case, then refuse to wager is above average, and you're motivated to refuse to wager. But instead of that going up, what happens is it just locks you in. You just lead to the same unchanged PJ and PV, right? So basically, the stable results are PJ equals 1, and any result where PJ is less than or equal to PV. All of those are stable, because if PJ is less than PV, then you'll just lock in your credences. You'll favor refuse to wager, and they'll just stay where they are. So I think this is actually a good result for the model, because it shows the model is still valid. And it shows actually something I've been worried about for a long time. I wanted an argument for the stability of atheism. I wanted it to be compatible with this model. And here we have a way in which refusal to wager can be stable. It maybe shouldn't be the only way, but if you just think there's more likelihood, maybe you think they're all ridiculously low. But as long as you think there's more likelihood of this virtuous God existing than the jealous God, you can continue with your credences unchanged, right? So I think it's actually a better result than for the first objection. Okay, anyway, there still remains large challenges about this stuff. And I think what would be interesting is if this model can be applied outside religion, philosophy of religion. I've been looking at environmental ethics, where you've got sort of infinite, negatively infinite outcomes. So you would need a model that integrates evidence and the dynamic updating, and I don't have that yet. So that would be another challenge. Okay, last one, I'll try to be quick, is infinitesimals. This is the most interesting though, and I'll just skip a lot of this, but there's a strong case for admitting infinitesimal, what I'm going to call infinitesimal deities, just to keep it, deities who have infinitesimal credence. And Oppy has this nice simple argument. Look, if you're willing to buy finite probability for these infinite reward deities, you should accept a sliver of infinitesimal probability for lots of other possible deities. So I think that's reasonable. There are other arguments about this, which I'm skipping. Oppy's objection is now, look, the whole relative utilities framework uses only real valued probabilities. It seems to not be neutral or not fully fruitful because there's no room for infinitesimal deities in this framework, right? So my response is that relative utilities are defined using real probabilities. There's good reason for that. But in fact, I don't have to exclude infinitesimal, not in the definition of relative utility, but admitting possible deities. And I don't have an axiomatic theory, but I thought, let's try a rough and ready, not rigorously worked out extension of the many wagers model. And I discovered that it's possible, but you have to make some trade-offs between neutrality and fruitfulness. So let me just, this is like, I'll try to be under 2 minutes. So here's 2 key questions about the trade-offs. So just look at, in question 1, this is the sure infinite thing question. Suppose A is something infinitely good that's guaranteed, and B is another infinitely good thing that's even better than A, but has infinitesimal probability. The sure infinite thing says no rational agent would trade A for B, right? The second is the sure, what I'm going to call the sure finite thing question. Could it ever be rational to trade a finitely good guaranteed outcome for something infinitely good that has infinitesimal probability? I'm less confident about this, but I actually think the answer to both questions is that it's not, nobody should do this, but the basic relative utilities model is open about these questions. The point I want to make, and this kind of unfortunately relies on that slide that I skipped, for these frameworks that use hyperreals and surreals, both questions are answered with an obvious yes. There are always going to be decision problems where it makes sense to trade A for B in each of these 2 cases. And I don't have to say that's always wrong, but I think a decision framework should be open to the possibility that we should never do this, right? So the question shouldn't be settled a priori. So arguably the basic relative utilities framework is more neutral than these other models, which are, they're smooth models. They don't have discontinuous preferences. So of course, if the probabilities are right, you'll end up trading away something infinitely good for an infinitesimal probability of something infinitely better if it's big enough, right? So anyway, I just wanted, so maybe I should skip this. This is a version of what I'm going to call the sure infinite thing principle. I'm going to skip this. I'm just going to go to this table here. So I thought about one decision problem. And it seemed to me, if I accepted a version of the sure infinite thing principle, and remember, this is the view that if you have an infinite outcome with finite probability, you shouldn't trade it away for something even better infinite that has infinitesimal probability. This is actually yet another version of Schlesinger's principle, right? Like, who would trade away, let's say you could get a pretty good eternal life where every day is pretty good for one where every day is much better. Like, would you trade this for an infinitesimal? Would you trade away the certainty of a good eternal life for infinitesimal, probably an even better one? When the fallback, remember, is Z, is some finite outcome. Okay, so I thought let's look at a situation where there's at least one relatively infinite outcome with positive probability. So here's one example where there's just one jealous god, n of these infinitesimal gods, and no gods. So this is actually the original wager. If you leave out all those middle rows and columns, it's just the original wager with a bunch of infinitesimal deities added in the middle. Okay, and I'm putting question marks for the payoffs. But because of this sure thing principle, I'm going to say they're all capped at 1, right? None of them is going to be better than the top left outcome. They're better, but their relative utility is at most 1, right? It's that picture we had earlier. So if that's true, and you do this kind of rough and ready calculation of expected relative utilities, what you find is you get P on row 1. It might be higher than P if these infinitesimal deities also reward wagers for the jealous god, but it's at least P. On rows 2, on the middle rows, wagering for the infinitesimals, it's going to be infinitesimal because it's just going to be sum of 1 times E1 plus 1 times E2. So it's going to be infinitesimal. on the last row, it's going to be at most infinitesimal. So basically, these gods get no purchase. Their relative utilities remain infinitesimal. They can never rise to the level where you would start accepting them. So basically, they make no difference to the whole wager if you grant this infinite sure thing principle. So anyway, I'm going to stop here. I've talked too long. So I hope some will be able to stay and ask questions. I am sorry I went longer than I thought. So thank you very much.
Thank you very much, Professor Bartha. That talk was really excellent and extremely interesting, difficult in some moments, but I think very, very inspiring. And I believe there are many questions. So please raise your hands. The first person I saw is
Should I
and this
stop sharing?
iPad. Could you? Oh, and Evan fails as well.
I stopped
So
sharing, but if people want, I can go back and look at individual slides. So
yeah, sure. So yeah, so feel free to ask whether when you want to go back to some of the slides.
yeah,
And even fails seems to be first, so please, the mic is yours. Sorry, you have to unmute.
I'm
Okay, no.
glad to defer to my competitor and go second.
oh,
Okay, so first we had someone I don't remember, but
Okay.
there was some iPad and then Aziz, but it
Uh,
seems you're first.
it
So
looks like,
even please,
am I the
yes.
first then?
Okay, so please go
I
ahead.
no, I mean, I actually don't know. I mean, I thought that even was the first,
I
but I think that the
I
person,
thought so, yeah.
I think the person that Maxine was talking about was maybe someone called Andy or something like this.
Andy and
Yeah, but I think what he
Andy
was just
Barton.
giving a applause, I guess, maybe. Anyway,
Perhaps. Yeah.
myself or even up to you, even.
Oh, okay, you started, so please continue, Aziz.
Okay, no problem. Yeah, so there has been this debate about the about whether whether pragmatic considerations should be considered have true barriers in any way. But I was wondering, for your perspective, for your argument, do you think that how do you classify how do you characterize truth or being closer to truth, or an argument being like uh, um, closer to truth, or addressing truth, or approximate truth, in accordance with your pragmatic considerations, if any, if you think that they are relevant, they are truth barriers in any way.
yeah. Okay, so these are so yeah. Let me just pause for a second. So yeah, this framework. Let's see. I don't know if there's any. I haven't really thought about this in terms of sort of accuracy or relation to truth. Um, I mean, I did, the only thing I mentioned that if this framework were to be used in a setting where evidence could be, like, I guess I'm assuming here, I was working in a framework where I wasn't assuming any evidence could be brought to bear. So maybe your question is like, suppose I thought we could try to combine this with like some model where you're worried about those kinds of considerations if we exported this to other infinite decision problems where evidence could be brought to bear. But of course, you might think that's the case in philosophy of religion, that we can bring evidential considerations to bear if we're talking about miracles or something. So I should take this more seriously and think about questions of truth. I have to confess, I hadn't really thought about it in those terms. Yeah, you're trying to reconcile this 100% pragmatic framework with worries about not. I guess consistency is there in the theory. Like but not a concern with convergence or anything. I haven't really worried about it at all. So I think the point I don't know if I'm missing the point entirely here. I think I have to admit I haven't really brought this in at all, except there was that brief acknowledgement that when I talked about evidentialism, that I'm not grappling with the big question, and I'm not, and there is this task remaining of trying to integrate this. This is a model, like in a way, one way to put the point is when we're thinking about evolutionary models, like we make a sort of a starting assumptions about populations and strategies and so on. And of course, those should be guided by evidence, right? But when you're just modeling, you're free to do what you like and so on. But like those models in a way don't bring truth to bear except in the initial modeling part. So I kind of was thinking of it as analogous, that you're starting with an initial set of priors, but you could argue that those should be constrained by evidence. Maybe that would be one way that the model could try to come into contact with considerations of truth, is to look at those prior distributions. So anyway, I'm not giving a great answer. I'm acknowledging the problem. And
No, I
saying
actually appreciate the answer. It's just that it's something that I've been thinking about because I'm actually working right now on philosophy of modeling,
okay,
philosophy of science, and there's this discussion about whether or not, I mean, to what extent they describe, to what extent they are accurate or not. That's why I asked this question. But at the same time, I appreciate the answer. It's just that I still struggle to understand because of pragmatic arguments to what extent they are supposed to describe some truth about the world, or whether or not they are not. But you can always, I mean, argue that they are not meant for that, right? To
yeah.
to make descriptions, to say that a proper, sorry, that my 1 year baby playing. It's to what extent they can describe the truth of the world, but you are welcome to say, I mean, they're not meant for that, right?
Well, actually, I just thought of a couple of things. So one would be, you could see them at the very least, like this equilibrium idea of stability as a kind of constraint. Like it's a constraint on the kinds of credences that's more substantive than is usually raised in these Pascalian frameworks. Like that they should be stable is not maybe settling things, but it's one constraint. The other, this occurred to me, is this could be useful as not almost like sociology. Like, why is it that jealous gods tend to be so prevalent, right? Like it's sort of an explanatory model, not, so you make these modeling assumptions. We're modeling not the truth about deities, but we're modeling people's beliefs, right? So we're actually saying, so that there's that kind of connection to truth, that not as a model, really modeling the metaphysics, we don't really have much purchase on prior probabilities for these various deities, but we can model societies and the kinds of beliefs people have. We can explain why certain, and that maybe that's what's been bothering me about this model and universalism, that universalism seems to be at least somewhat popular and stable, and I can't seem to account for it very well, right? Evidentialism, I feel better now because, like, I actually don't want this model to inevitably vindicate Pascal's wager, right? I don't want that. I want it to be somewhat neutral. So you can rule out certain things, but so anyway, this is not exactly an answer either, but it's maybe relevant to your interests, that we can show, like, if this model is correct, you can, like, it is kind of puzzling. Why are these jealous deities so prevalent? They seem kind of repugnant in some ways, but you can sort of see why on this model there's a kind of pressure. And other models, what happens, I mean, there's all kinds of examples where you see various configurations that are unstable, that get destabilized when you introduce a jealous god as a possibility, right? So it's kind of interesting how this modeling works. So anyway, it's kind of a whimsical answer, I guess. I don't mean this as serious sociology, but yeah.
Yeah, thanks.
Okay, thank you. It was a really interesting part of the discussion. Okay, and now please, Ivan, ask your questions, and
Yeah,
if there is anybody, please show us by raising your hands. Yeah.
I'm very very glad that this topic came up because I have not thought for quite. I haven't kept up to date on the debate. I knew there were these other questions. I want to make three quick observations and then a question. The observations are these. First of all, most people are math dunces. And
Oh,
they won't understand any of this, and I'm afraid they'll be left in the dark. Secondly, what if there are indecisive gods? These are not indifferent gods. These are gods that change their mind about whether to be nice, jealous, or etc. And maybe they have a roulette wheel, and every once in a while they think, "Oh, I want to change my identity here," and they spin the roulette wheel. And the third possibility is if you have many gods and you win the prize and you get a jealous god and you get to go to their heaven and some of the other gods, or you get a very nice god. Some of the other gods are unhappy with that and they do their best to ruin your life in the good heaven. I don't know how you would deal with that. But here's my global problem. It's a little bit related to Moser's. Um, in at least the history of Christian ethics, it seems to me that the vast preponderance of thinkers have opted for some version of deontological ethics. And it's interesting that Pascal's wager really is a consequentialist argument. But it's sort of odd to see people suddenly switch to consequentialism. And to bring out that oddness, one has only to think about the conversation between Alyosha and Ivan Karamazov in the upper room of the tavern, where they are debating these issues. And it's just before Ivan comes up with the story about the Grand Inquisitor. And Ivan asks Alyosha if the price for heaven were the unatoned tears of one small child that had been abused, would you accept that? And Alyosha says no. And as far as I know, Dostoevsky does not, either in The Brothers K or in his other novels like Crime and Punishment, give any response to that problem. And that, it seems to me, in a way, vitiates the whole project of Pascal's wager.
okay, good. This is a great discussion. So the math dunces problem, it's a real problem. I don't know what to do because I thought with this group for sure I could talk about formal stuff, but I agree. But maybe one thing that will help, this is also sort of trying to address the worries about the impiety of the whole Pascalian project, is like in the back of my mind is a thought that by turning around the argument, like this relative utility stuff and the evolutionary stuff is meant to kind of invert the argument and turn it on its head. It's not an arm twisting argument that, out of this narrow desire to save your own skin or something, you should take the wager. It's more an attempt to show that one can coherently have this odd preference structure where something is valued infinitely, that it's not completely crazy that there's a sort of a decision framework that makes this work. And you could even think of the infinite reward in a much less narrow way, like the moral orders, is I have to be careful about that, because why would it be tied to wagering, right? If it's something impersonal like a moral order, it looks like it wouldn't be linked to your own. It would be there whether you wager for any. But I'm trying to make it a little less mercenary. This framework is supposed to make it a little more appealing. It's a way of rationalizing a set of preferences that takes this religious takes the belief seriously. And anyway, so that but it's true that the pictures even the pictures don't really help people if they like. And I did go pretty quickly, I admit, even though I went over time. It was still too quick, to explain it. But I wanted to talk about the Oppy stuff. I couldn't really do that without explaining relative utility. So anyway, I'm sorry for the murkiness in places. So anyway, so I'm kind of rambling here. The indecisive gods, that is really an interesting point. My suspicion is that if you put in indecisive, like, you'd have to model it, right? You'd have to say there's some like just as a starter, you would say there's some god who wavers between A, B, and C or something. My suspicion is it's going to be a bit like the mixed strategy case, that they will end up coming out behind one of these consistent deities. So support for them will actually drop off. So they may exist, but wagering for them is a bad gamble, so to speak. And it will kind of, in this dynamics, it will end up dropping. But I don't know that. But I'm going to think about it, because I think it's like, basically, I by no means want to close the door on these many gods. There's endless versions of many gods objection. But I think this one, it might be possible to answer it by looking carefully at one of these. Now, if it's completely arbitrary, I don't know how I would model it, but I think there is at least to me, it's sort of enough of a resemblance to the coin toss, the mixed strategy, that I think it's kind of like I had in that pantheon, I had initially pointless gods who don't reward anybody, right? Those ones, there's no reason to believe in them. They're sort of like the opposite end from the universalist one. I suspect the same is going to be true of these wavering ones, that it'll be if it's totally even-handed, they won't put pressure in any direction. But anyway, if you limit their options, they might put some pressure towards those options, but they'll still come out behind the ones who are sticking to a consistent reward pattern. So anyway, I don't know this, but it's a thought. So then the question you asked about the many gods. So this is something that I just realized, like, in the background, I was assuming there's only one. So like, I wasn't really, when I talk about the many gods, I still am thinking these are many epistemic possibilities, right? They're not that. So, but if you
had cartels.
Pardon?
You did have cartels.
Well, the cartels don't actually all exist. Like, even with the cartel, you're right. The way I describe them, it sounds like they all I describe them as if they all existed, but I wasn't really thinking that. I was thinking that in your mind, you're conceiving that if God exists, it's going to be one of these possibilities, but only one, right? So, but I should consider there are polytheist religions, so I should consider that as a possibility where there's more than one. But in my mind, I hadn't really meant the cartel to be literally these all exist. It's more that the possibilities are all there, right? I had meant them to be possibility. But anyway, that's yet another point that needs to be considered, is literally many gods, like not just one, but there could be more than one. Anyway, so I don't know if I've answered all your objections. The last one I take to be a version of the problem of evil, like that if there's basically or I don't know, maybe there was a bunch of thoughts in there. There was the switch from deontological to consequentialist views. So there, I mean, I guess it's a pretty deep question. And Pascal's own view about the wager is open to, it's open to question. It's kind of some people argue that this is, somewhat of a subversive. His target audience is these kind of cynical aristocrats who basically don't take religion seriously, who he's appealing to their gambling instincts. So it's kind of like, even if I come to you where you live, you will see that you should take this more seriously. You're saying, so he himself is not, it's questionable whether he's motivated by these. Doesn't seem to be, if you read the rest of the Pensée, he's not narrowly, thinking about his own skin or his own salvation. So I guess I'm falling back on this idea of the wager as imposing constraints on kind of acceptable patterns of wagering and acceptable credences. So maybe that's the best I can say for now, is that there's something troubling about unstable, even if you are skeptical of pragmatic arguments, there's something troubling about self-undermining credences. You believe something and then you realize if you were to follow through and make that wager, you would undermine the very credence you started with. So that's the kind of fallback position. So I don't know, I hope it's a reasonable start to answering.
I applaud doing the formal stuff. I think that's intrinsically interesting and lots of fun. The Ivan problem, look, I mean, it's a global problem because there are these cases of injustice that Ivan says can't be atoned for. And under those circumstances, there's no way you can avoid that question in the end, even if you solve the formal questions about wagers.
I agree. This is just part of the story. Yeah. And I don't, as you say, I don't remember Alyosha ever coming to grips with this.
Well,
I've read it twice, the book, and I don't remember. Yeah. So,
I think the book does come to grips with it, but not in the sense of anything that is articulated verbally.
It's just his actions or choices or something.
It's a question of, it's much more complicated than that.
Yeah.
Okay.
Thank you.
Thank you for the discussion. We are a bit out of time, but running out of time. But still, I think that if there are any questions, you can still take this opportunity. Mihai, okay.
Okay.
Please
Hello,
continue.
Professor Bartha. Nice to meet you. It was a great presentation. I have a little question regarding some epistemic, commitments of your model. More precisely, in the classical model of the wager, we have only two possibilities: accept the existence of God and rejecting the existence of him, let's say. But however, let's suppose that we have a third possibility that, let's say that it is a kind of doxastic neutrality, but that kind of neutrality which is inquisitive. So imagine an agent who does not succeed in collecting evidence favoring the existence of God, but however, he tries to obtain more evidence. In that scenario, I can imagine that God will reward the person trying to collect positive evidence regarding his existence. So in this regard, I imagine that his utility after his life, it will be the same with a person or equal to the same with a person who decides to believe in God's existence. So in this case, for example, my question is, the introducing that possibility in the model can affect, for example, the utility of literally believing in God existence.
Okay. So yeah, so let me think about this. So it's something like Oppy's one, but it's more open-minded. It's kind of a refusal to wager, but it's an open-mindedness to evidence.
Yeah,
So
right.
yeah, so it's an interesting idea. And I don't want to assimilate it to one of the other tables, right? Like your whole point is this would be a
Because
different.
in all these tables, there is a lack of this possibility. There is
Yeah.
always an acceptance or rejection, but the third possibility is lacking.
So now it seems like uh, okay, first of all, this could be, and I want to acknowledge it, could be a weakness of the whole framework.
Exactly.
So that's fine.
Exactly.
But it could be that there's a way, like maybe this needs to be modeled. Like you, for example, you said it's possible that this could be rewarded, right? Like so
Because
so
a great God will appreciate the
yeah,
fact that that person is inquisitive and in the same time he is very reflexive. So maybe he doesn't collect positive evidence, or there is a proportion of positive evidence directly correlated with negative evidence regarding God. So for that scenario, God decides to say, okay, you are a virtuous person because you are inquisitive, epistemically inquisitive. So
right,
I decide to grant you the great prize.
right. So
Okay.
so this makes me think that okay, so just by way of trying to express a hope that I might be able to think about this with this framework.
Mhm.
The Oppy case was initially exactly a counterexample to me. Like I thought this is a real problem, but then I thought the model, you can adapt this model, and I think what I remember I argued that in this case you can show there's a kind of stability of the refusal to wager on if that's like
Yeah.
as long as you think the
Point of
virtuous God.
equilibrium.
So what I think this is a different. It's not the same. It's not the
Right.
same as the Oppy case, but there might be a way. Like you're still going to need to model your columns, right? And
Yeah.
you seem to be adding a column for this kind of deity who rewards the open-mindedness, like who. So I think it might be interesting to at least try to not to assimilate it to one of the other examples. But I didn't mean like in all my tables, of course, I start with the very simplest table, but it might be possible to model
Verifying
this,
them.
yeah, in some interesting way.
Yeah.
And maybe
Exactly.
it will end up being different from the Oppy virtuous God, but it's a different kind of virtuous God, right? It's that's so what I mean is that may be an analog. Not that that is the same solution, but the
Yeah.
way that was handled maybe would give us a way to think about this case. So I think that's great to to think about these extra cases. So in fact, I hope you see the thrust of my talk has been that there's a
Sure.
basic framework that's sort of neutral and can accommodate different additional modeling assumptions, right? That's kind of this is so this is really that is sometimes a frustrating line of argument because like how do you attack such a position, right? Because the person's just going to say, oh, maybe I could model this, but I think you know I will admit failure for the universalism. I so far have not found a good way to really model universalism. So it's not like it's not a completely amorphous theory. But thank
Okay.
you. This is a good objection.
Thank
Okay,
you
I
too.
also wanted to thank you, Mihai, because actually I had something similar for the end,
Okay.
but an option which could be considered as an opposite to what Oppy proposed. So this virtuous God, namely, we could label it as a mathematically obsessed God. So a God who says, I gave you a reason, something like reason. It enables you to do mathematics. So I want you to do mathematics. I want you to gamble. I want you to use your reason in order to discover that I really exist. So uh, whenever you do that, then you are rewarded. But if you refuse, oh, then it's bad. So
If you solve my equation, if you solve the
it's a
equation of my
variation of,
existence,
yeah, exactly. But
yeah.
that was what came to my mind, and perhaps when this variation is much stronger and very precise. So God's we consider a God that wants you to do that, to wait. Then what would be the result in the table? That's my question.
It's a bit
And also I wanted to
Descartes.
ask you whether have you included to take
Yeah.
into account
So
such a kind
that's fun to think about.
of
That's kind of like Descartes' God, right? It's sort of except that Descartes thinks that the natural
yeah,
light,
but
we all have the ability. It's kind of
exactly.
like a
So we
more,
should do that.
yeah, like Descartes thinks God is hidden, but gives us the clues to figure out that right. So, and it's sort of within everyone's reach for Descartes, but yours is a more elitist, I guess. Like there's sort of this problem that that as the first objection, or as Evan's objection is that most people couldn't. This is putting it out of reach for most people that if they have to go through this gambling argument. So what would what would I say about this? That yeah, like suppose, okay, I don't, it's fun to think about this. I don't have a good answer right now, but it's like suppose I carried this whole project out, and in the end, I'm completely convinced that there's no objection that can't be answered convincingly with sophisticated, elaborations of this framework or something. I don't believe that for a minute, but if that were true, but I realize that hardly anybody can understand this argument. I don't know. It's very funny that the whole thought that this I don't know what to say. It seems like okay, wagering that God is like that, like wager, and you have to. So what would be the wager is you have to believe not just that God exists, but that it's that particular deity, right? Is that the idea? Or you have to, maybe it's that you have to make the wager because of those reasons. Like it's something like that, right? Like it's not just believing in God, but believing for the right reason, which is you've gone through the whole mathematical argument.
Wagering, according to Marcin, if I well understood, is just the consequence of a previous attitude, epistemic attitude. So, in case I don't know, you are right with your computations, the
Yeah,
consequence of it, I don't know, a right rationality, is to wager on God's existence. If I well
yeah.
understood Marcin's position.
So yeah.
What
Or
could
I
be
wonder if
that?
you could.
Yes.
I wonder if you think Gödel had a similar, or maybe thought you could, thought the ontological argument worked or something. Like if you just go through that, work this out, then anyone can see, maybe not anyone, but uh, uh. So what would I say about this? Like I
Yeah,
don't
yeah,
know. I guess
but the critical moment of this option was that well, we perhaps we should wager for such a God because uh, this is a God that wants us to not to
yeah,
refuse,
there's a
but
kind of
to continue this
self-reinforcing.
game. And he rewards us when we do that, but he's
Yeah.
really angry when we refuse this
So
game.
I don't know. I mean, my fear is that if I'm able to solve this, the next question will be, what about a God who punishes mathematicians and who doesn't want people, who wants the soul of faith, like, more Dostoevskian God who doesn't
Yeah.
have any patience with these bureaucrats or, this kind of petty petty, who
Yeah,
has to go through this.
exactly. But
So,
I,
so
I actually asked this question just to maybe ask you whether you consider it inspiring and maybe it's worth uh,
yeah. Well, okay. So
including
I
it
mean,
in the table or not because it's too silly, I guess.
no, it's not. Like, I
It's not
mean,
okay. That's
you kind of got me because I claim to have this neutral framework, right? So I should be able to think about any of these possibilities, like, and some of them, like the indecisive one, I think there might be an answer there. Maybe there's an answer to this neutrality example, but I'm sure there will be many where I don't know what to say. And like this one, I'm going to think about too. Basically, that's for me, that's a big benefit of this talk is I get these great questions and I can like say, okay, is this, because you kind of think about stuff for a while and your imagination only goes so far. So it's great to hear these other possibilities. So I don't have a quick answer, I'm afraid, to this one.
that's fine.
I did try to think about like I did try to think about this. Deities whose behavior in offering the reward is not linked to wagering. Like, but it's not quite your example. Like yours is still a kind of a wager, right? Like it's a wager based on the calculation, on mathematical calculation. So, but I was saying a deity whose rewards are not assigned at all based on, they're not connected to wagering behavior, is equivalent to a deity who doesn't offer rewards. Like in terms of this framework, they end up dropping out because there's no reason to wager for deities whose rewards behavior is not linked at all to wagering, right? So that's kind of what happens to the nice god. But anyway, yours is not like that. Like it's maybe like, okay, so if it were just that the deity rewards mathematical prowess or something, like, and then I could say those will drop out because wagering for such a deity has no benefit, right? Maybe. But yours is linked to wagering. Like you're saying, this deity rewards those who wager because of the reason they've gone through this mathematical reasoning specifically about wagering, and they've kind of so I don't have, it looks like it looks a bit like an extreme jealous god or something. Like somehow it could fit in to, like, it could end up being, if you actually have an appreciable credence for this god, maybe that's all I can say right now is it's one more jealous god type of deity. And if you actually have a starting credence for that deity that's high, it could take over. But what if it's there but not very high,
Yeah.
right? It might end up dying in this dynamics, right? So I don't know if that's true, but
Okay,
it might be.
that's
It might end up working.
fine.
Yeah.
Sure, that's fine. My intention was just to show
Yeah.
some opposition to what Oppy proposed. So this virtuous god who wants us not to wager, uh,
Yeah.
just like this. But it was just as a kind of maybe inspiration. We got inspired by you in many ways. So thank you for that. And I think it's a good time and a good moment, yeah, to conclude.
Okay.
Namely that, well, I personally, and I think not only me, but all of you got really inspired. We'll for sure think about it, and that we are really, really grateful for your speech, for a very clear and excellent talk. And yes, for sure we benefit from that. So thank you
Okay.
again.
Well, and thanks to all of you for inviting me in, for hanging around for 2 hours. It's early in the morning for me, but I don't know what time it is for you. But thank you all. Great questions. I wanted to ask: is Michael Wright? Are you the Michael Wright from the Michael Wright archive? The physics stuff. I'm not sure. I just thought, I was curious whether it was the same Michael Wright. But anyway, the stuff in
Yes.
quantum gravity. But anyway, I'm not sure. But anyway, welcome everybody, and thanks for being here. And I will try to come to future sessions too. Now I've seen what this group is like. So Thank you.
Thank you very much. We are glad to hear it.
Congratulations.
Congratulations, and yes, we for sure we will be in touch, and we hope for the future events and so on. For sure, we will inform you about everything we organize. That would be a great honor for us to have you.
Okay.
So thank you for today, and
I just want to announce the
with
next
that, yes.
the next webinar. It's going to take place December. We are just doing bi-monthly now. And the next webinar we'll have a theologian this time. It's Tom Yard. He's from the Nazareth Theological Seminary. So he's going to come with a very bold claim. He comes with defense, and he's going to come with an opposition to the concept of divine omnipotence. So he's going to claim that he's going to propose that what he calls omnipotence should be better construct as a divine attribute instead of omnipotence. Now, his claim, just a few seconds, is he wants to claim that instead of like the traditional divine attribute, the perfect being theology, the traditional classical theism, which claims that divine attributes arise either from omnipotence, like Richard Swinburne would say, or that divine perfection, if you believe in divine, on the perfect being theology. He's going to claim that divine attributes derive from God's love. So God's love is going to guide his actions, in particular his powers as well. So if you want to hear about this, join us in December. I'll announce that. Thank you so much, guys. Again, Professor Bartha, we really appreciate your talk, and see you again in future. See you guys. Bye-bye.
See you. Bye-bye.